Hello. All right. So I'm going to try to explain the lab 3, the controlling evaporative cooling lab. Um, I'm sure most of you have figured this out already, maybe, hopefully. But if not, I had like a little epiphany, mind blown moment. So it looks like, there's 3 exercises. We measured the wet bulb and dry bulb temperatures in the different ovens, like the combi oven, 2 different degrees, the CVAP, and the room temperature. And then the second experiment was to boil water, covered and uncovered. And then the last one was the chickens, which we all saw was a giant disaster. So basically, with the first experiment, you were trying to figure out the wet bulb and dry bulb temperatures. When you had the wet bulb temperatures, which was the moist sensors, you were measuring the moisture, right? The wet bulb temperature, which was the temperature of the evaporation of the surface of something wet. Um, Kind of like the chickens. You know how he said the chickens are wet, so that's going to be your wet bulb temperature, and it's going to be cold and wet. So we measured that, and then theoretically, when you did the wet bulb temperature reading in the CVAP, it should have been at the 71 degrees because it's a completely moist environment. So all your readings should have been at 71 degrees Celsius and stayed that way. So that's that. We'll go back to those. So the second experiment was boiling water with it covered and uncovered. It was just boiling water, but the real point home for that is when you covered the water, you don't get any evaporation, so your cooking time is shorter by a minute or two because you kept all the water vapor and evaporation contained, so you kept the energy in there. Um, which is a humid environment, you know what I mean, like in the CVAP. Whereas when you had it open, it took longer and it evaporated more out, which was your evaporated cooling, as if you just put a chicken in a regular oven. So going back to the first thing, the wet bulb temperatures, and going back to thinking that if you have a moist environment, like in the CVAP, and you measure your wet bulb temperature, it's going to be at that temperature, or should be. And then taking that with boiling water, and you boil it with the cover on, you keep the evaporation and the energy in because you're keeping a moist environment. And then the reason why we cooked the chickens in the CVAP was because we were trying to keep a moist environment completely so that the wet bulb temperature would be similar to the dry bulb temperature, which is what should have happened in exercise 1 when you put the 2 thermocouples into the CVAP. But so both of those together with the chicken was supposed to round everything together, putting the first experiment with the second experiment together. First experiment showing that when you have the wet bulb temperature reading in a completely humid environment, as in the CVAP, then it should be similar to the dry bulb temperature. And then with the boiling water, you can see that it took less time when it was in a humid environment because it was covered and all the evaporative cooling was non-existent. It was contained inside the pot. And then so that puts together with the chicken, that when you put the chicken in the CVAP, then you're containing all the evaporation and evaporative cooling, so you're keeping all the energy in there. So technically your cooking time should be cut like lower by a lot because you're keeping all that heat energy in there and you're keeping your wet bulb close to your dry bulb temperature. So yeah, I know that's kind of how I thought about it and explain it to tie all those together. Maybe someone else has a different explanation, but that it made sense to me. All right, bye bye. Oh, snow day. Woo!